So just an overview of theoretical probability. In order to calculate theoretical probability, what we do, is we take the number of possible outcomes and divide that by the number of favorable outcomes. So when all outcomes are equally likely, the theoretical probability that an event will occur is, and then that's how we calculate theoretical probability. Remember, theoretical is before an event happens. So for example, here it says, a desk drawer contains 5 black pens, 7 blue pens, and 2 red pens. If a pen is chosen from the drawer at random, what is the probability of choosing a black pen? So what is the probability before that thing even happens? Okay, so we have 5 black pens, 7 blue, and 2 red, right? And so what we want to identify is what is all the possible outcomes, the total number of pens that we have in our desk, divided by the number of favorable outcomes. So our favorable outcome is we want a black pen. There are 5 black pens, so we can put that right there. Again, we're trying to see what's the probability of us choosing the black pen. And so the total number of pens would be 5 plus 7 plus 2, which is 14. So 5 over 14. Whenever we put that into our calculator, we get that's approximately 36%. Okay, so that is how we calculate theoretical probability. The number of all possible outcomes goes on the bottom. The number of favorable outcomes goes on the top. Okay, questions still about theoretical probability? Questions? No? Okay. So today we're going to look at mutually exclusive events. So 2 events are mutually exclusive if it's impossible for those 2 events to occur at the same time. So the intersection of these 2 events is going to be equal to 0 because those 2 events cannot happen at the same time. For example, if I were to toss a coin, event A would be that coin landing on heads, while event B would be that coin landing on tails. Well, obviously, if I flip a coin, I can't get both heads and tails at the same time. And so those 2 events would be mutually exclusive, right? You can't get both heads and tails while flipping the coin once. So those events would be mutually exclusive. So here's an example of mutually exclusive events again. It says a 6-sided number cube is rolled once. What is the probability of rolling an even number and an odd number? Well, all odd numbers are not even numbers and all even numbers are not odd numbers. They cannot happen at the same time. You cannot have both an even and an odd number. And so if I had a 6-sided die, that means I have, this is my sample size. My sample set, sorry, I can pop the possibility of rolling a 1, possibility of rolling 2, 3, 4, 5, 6. A is going to be all my even numbers. So 2, 4, 6. And B is going to be all my odd. 1, 3, and 5. And so what I notice is there's no instance in which they have anything in common. Again, you cannot be both even and you cannot be both odd at the same time. So those 2 would be mutually exclusive because they cannot happen at the same time. Non-mutually exclusive events can happen at the same time. So there is an intersection point basically. So again, a 6-sided number cube is rolled once. So this is my sample set. I can get any of these numbers. A is the probability of rolling a number less than 4. So all of these are rolling a number, less than 4. So these are my number sets. So 1, 2, and 3. And B is rolling a multiple of 2. So 2, 4, 6. Well, what I see there is I have an intersection point, and so that means 2 will move to the center. And 4 and 6 will get placed over here. And so because there is that intersect, and that leaves 5 that we didn't highlight, and so 5 would just go on the outside. So that means that there is a point where those 2 things can happen at the same time, where event A and event B can happen at the same time. So those would be non-mutually exclusive. So mutually exclusive means that they can absolutely not happen at the same time, right? There's no intersection. So the way that we go ahead and calculate mutually exclusive events is we use this equation, P, A, or B is equal to P, A, the probability of A plus the probability of B. So basically what we're calculating here is the probability of A or B occurring is equal to the probability of A plus the probability of B. Okay, so this symbol represents 4. So 4. Okay. Now what about, how do we calculate non-mutually exclusive events? Well, we use the same equation, except we do have a possibility of having P and Q. I mean, not P and Q, A and B, which is this one right here. So P, A and B, sorry. And so what I want to go ahead and do is just subtract by the probability of A and B. So this would represent and. So these are the equations that I would use to calculate mutually exclusive events and non-mutually exclusive events. Okay, so remembering these equations is key, remembering these. Right now, I'll give them to you, so you don't necessarily have to remember them, but each equation represents each thing. Okay, so let's look at an example problem of using this. So what is the probability of rolling a 3 and an even number on a standard number die? Well, event A is rolling a 3. That's my first event, or event 1, rolling a 3. What is the probability of rolling a 3? Or, so event 2, or rolling an even number? Okay. And I know I have a standard number die, a standard cube, so my set is going to be 1, 2, 3, 4, 5, and 6. And so basically what I can go ahead and do is I can go ahead and actually create a diagram that represents this and see if there is in fact any intersection points. So probability of rolling a 3. So a 3 would go and invent A. The probability of rolling an even number, 2, 4, and 6. What I see is there's no overlap, right? There's no common points. And so that means that I have a mutually exclusive event, right? Because mutually exclusive means that my two things cannot happen at the same time. That means I'm going to use this equation right here to solve for that probability. So how many of my numbers are in event 1 or A? 1. 1 out of my 6 numbers is in event A. How many of my numbers is in event B? Well, I have 3 out of my 6. I just add those together. That gives me 4/6. So the probability of rolling a 3 or rolling an even number is 4 out of 6. Okay, so the first thing I want to do is identify what type of event is occurring. Do I have an overlap? Can my events happen at the same time or do they not? If they do not, you use mutually exclusive. If they do, you use non-mutually exclusive. Because these two do not have a common point, I know to use my mutually exclusive equation. And so therefore, I just go ahead and solve. PA would represent my probability of event 1 happening. So this expression right here. And my PB would be the probability of my second event happening. So this one right here. I'm just adding those together. What about an example of non-mutually exclusive? This says a car manufacturer is studying the reliability of its car models. The study confirms that the probability of brake failure is 5%, and that the probability of both brake failure and overheating is 1%. If the probability of brake failure or heating is 13%, what is the probability of overheating? So event A is going to be my brake failure. So what is the probability of my brakes failing? Event B, or 2, is going to be my probability of overheating. And I'm told some information about these probabilities. The study confirms that the probability of brake failure is 5%. And the probability of both brake failure and overheating is 1%. So where those things happen at the same time. So I already know that those two things can happen at the same time, event 1 and 2. And so I know that my two events are not mutually exclusive because they can't happen at the same time. So the probability that 1 and 2 will happen at the same time is 1%. if the probability of brake failure or overheating is 13%. So one or the other is 13%. What is the probability of overheating? Okay, well, I know right now that my two events are not mutually exclusive because, again, it said that they could happen at the same time. So I'm going to use this equation right here. And then I'm just going to plug in what I have. What am I given in my expression? So I'm told the probability of event 1 occurring. I'm going to go ahead and change this to a decimal. So event 1 is 0.05. Plus, I don't have the probability of event 2. So I have the probability of A and B. Yes, I do right here. And that is 1%. So I'm going to create a decimal. 0.01 is equal to, do I have the probability of one or the other occurring? Yes, I do right there. Create that into a decimal. And so now, given this information, I can solve for my probability of just overheating. So basically, I would either put this in my calculator, where probability of B is X. So if I'm going to put that in my calculator, I want to make sure that I just have one variable there. Or I can go ahead and do it algebraically. Okay. So minus 0.5 on both. Oops, that's horrible. Minus 0.5 on both sides. 0.08 equals probability of B minus 0.01. Move this to both sides. So therefore, my probability of B is equal to 0.09. Or if I wanted to change that back to percentage, 9%. So my probability of overheating is 9%. Okay, so in this question, I know that these two are not mutually exclusive because it tells me what is the probability of both occurring. So because both are occurring, those cannot be mutually exclusive. They have a common point. Here, the information is given to me. The probabilities are given to me, right here, right here, right here. And so I'm just plugging that in to my mutually exclusive equation, which we got over here. And then solving for, obviously, the probability here of overheating, which is probability of the event B or event 2 happening. Okay, so depending on how your question is worded, you can tell whether something is mutually exclusive or non-mutually exclusive. And then depending on that, you'll know which equation to use. Okay, so last thing we're going to look at today is independent events. Two events are independent if the occurrence of one event has no effect on the probability of another. So if two events occur at the same time, so they can happen at the same time, but the first thing that happened doesn't affect the second thing that happens. So for example, if I have a penny and a nickel, which are both tossed at the same time, the penny lands on heads and the nickel lands on tails. Well, they're both two separate coins. One doesn't have an effect on the other, right? There's no effect. And so the event of the nickel landing on tails is not in any way affected by the first toss of the penny. So events are independent if they are not affected by the other event occurring. Okay. We go ahead and represent this equation. To find the probability of two independent events, we use this equation right here. P A B is equal to PA times PB. So this is the probability of both of those things occurring. The probability of A and B occurring. When I know I have an independent event, I know I need to use this equation to solve for the probability of both of those events occurring at the same time. Okay, so let's look at an example. This says Emil owns 50 CDs. His collection consists of 7 country, 14 rap, 3 jazz, 10 pop, and 13 rock. So let me just go ahead. Country, rap, jazz, pop, and rock. Okay. So those are all the different CDs he has. If two CDs are randomly chosen from the collection, one at a time, and replaced after each choice, what is the probability that he first chooses a pop CD and then chooses a rap CD? So these two events do not have an effect on one another because what it tells me is they're chosen one at a time, and once I take one CD away, I replace it by another. Okay, so that means there's no effect on the other. So these two events are independent, and so therefore I can use my independent equation to solve for the probability of you doing what is asked. Okay. So I want, what is the probability of a pop CD? So the number of pop CDs I have is 10. What is the probability of a rap CD? The number of rap CDs I have is 14. Over my total number of CDs. So if I add this together, 7 plus 14 plus 3 plus 10 plus 13, that gives me 50 CDs. So there's 50 total CDs. If I select a pop CD out of those 50, and if I select a rap CD out of those 50, what is the probability of first choosing a pop and then choosing a rap? So I put that into that equation, multiply across. And this is the expression that I get for that probability. If I wanted to, I could go ahead and plug that into my calculator and see that it's approximately 56%. Okay, so if two events are independent, then we use the independent equation, and that will give us the probability of those two events occurring. Okay. So here are the two things we went over today. We went over mutually exclusive events. These mutually exclusive events cannot occur at the same time. There's no intersection. It is one or the other, cannot be both. And it's known as the addition rule. It's basically known as the addition rule because the equation looks like this. So it's the addition rule because it contains that addition sign in the center. An independent event can occur at the same time. It does have an intersection. It can be one and the other, and it's known as the multiplication rule. It's known as the multiplication rule because it uses multiplication times probability of B. Right? So depending on what word problem you'll get, you'll know whether to use mutually exclusive or independent. And then if you're using mutually exclusive, you use this equation. If you're using independent, you use that equation. So that is basically the gist of everything we're going to go over today. We'll go over practice problems tomorrow. But if there's no other questions, you guys may log off. Bye, guys. Bye, Ryan.